In this topic on linear regression and correlation, we want to examine the relationship between two variables. The technique here are good for variables that can be measured quantitatively and have interval or ratio scales. The topic is split into two main areas, namely linear regression analysis and correlation analysis. For linear regression, the aim is to find the best fit linear equation so as to relate a dependent variable y to an independent variable x. We can then use the equation to estimate or predict y given a certain x. For correlation, we analyze the strength and the direction of the two variables. In this section, we are going to learn about this visual aid called a scatter plot. A scatter plot is like a graph with a collection of points, and each point represents a pair of x and y coordinates. To draw the scatter plot, we let the vertical axis represent the dependent variable y, and the horizontal axis represent the independent variable x. And we plot each pair of x and y accordingly. The purpose of a scatter plot is to help us examine if two variables are related at all, and if they do, what type of relation exists between the two of them. In this example, we are shown the sales info of 7 people. How do we draw the scatter plot? Well, the number of funds sold is dependent on the number of calls made. So the number of funds sold is the dependent variable, which is represented on the y-axis, and the number of calls is the independent variable, which is represented on the x-axis. Next, we plot the x and y coordinates pair by pair. The first person, Dick, made 200 calls and sold 60 funds. So find the intersection of x is equal to 200 and y equal to 60. The second person, John, made 100 calls and sold 40 funds. So find the intersection of x is equal to 100 and y equal to 40. Do the same for the rest, and you should get the completed scatter plot. Once we have drawn the scatter plot, we look out for trends. Using our eyes and some personal judgment, we ask ourselves if there is a line that can approximately fit through most of the points. The type of line that we see will give us some indication of the type of relationship between the two variables. There are some typical types of relationship that we should be aware of. First off, direct versus inverse relationship. For direct relationship, the general trend is that as x increases, y also increases. For inverse relationship, the general trend is that as x increases, y decreases. Next, linear versus non-linear. For linear relationship, there is a straight line that more or less describes or captures most of the points. For non-linear relationship, there is a curve or non-linear line that more or less describes most of the points. Finally, we say that two variables have no relationship if there is simply no obvious trends between them. Let's learn to identify some of these relationships. In this first diagram at the top, we can draw this imaginary line through the dots. Also, as x increases, y also increases. Hence, this is a direct and linear relationship. In the first diagram at the bottom, we can draw this imaginary line through the points. Also, as x increases, y decreases. Hence, this is an inverse and linear relationship. In the second diagram at the top, we can draw this imaginary curve through the points. Also, as x increases, y also increases. Hence, this is a direct and non-linear relationship. In the second diagram at the bottom, we can draw this imaginary curve through the points. Also, as x increases, y decreases. Hence, this is an inverse and non-linear relationship. In the third diagram at the top, we cannot draw any imaginary line or curve through the points, as they are quite randomly scattered. Hence, there's no relationship. For the remainder of this chapter, we will focus our attention on only linear relationship. In our earlier example, we had drawn the scatter plot. Can you identify any relationship from the scatter plot? Well, we can see that as x increases, y also increases. We can also draw this imaginary line through the points. Hence, this is a direct and linear relationship. Armed with this revelation, the management can probably show some concrete evidence and advise its salespeople that the more calls you make, the more funds you are likely to sell. In this next example, a scientist has collected some data and has drawn a scatter plot. Could you advise him if there is any relationship between the atmospheric pressure and altitude? Well, we can see that as x increases, y decreases in this case. We can also draw this imaginary curve through the points. Hence, this is an inverse and non-linear relationship.